Hello everyone, today's video is going to be on the difference between open channel flow and pipe flow. I'll try explaining using practical examples on some of the works which I've been personally involved with, and I'll try to make the video as simple as possible. This right here is an open channel, and this in fact is the head race channel of the Umlun microhydel project. Open channel means that the channel is open to the atmosphere and as such is subjected to atmospheric pressure, and here the flow happens due to gravity, and there's a slope from the start to the finish, and in this particular case the length is 230 meters and we have dropped it by 1 meter. This means that the slope is 1:230. There are different types of shapes of the channel also, and some may be trapezoidal, some may be rectangular, etc. In this particular case, the site is 45 centimeters on each side, or 1.5 feet, and this means that this is a squarish sort of channel. There are some factors which affect the flow also. For example, the surface may not be so smooth, there might be some stones, etc. In this particular case, the walls have been, the sides have been plastered, so the flow is very smooth, and you can see the velocity of the water also is quite good. Drains, nalas, streams, rivers, these are some common examples of open channel flow. So I hope you have understood a very simple concept of open channel flow, and let's have a look at the pipe flow now. Now pipe flow, as you can see behind me, happens due to hydraulic pressure, and you can see the pipe, it comes down like this and then comes up, but still water is able to flow here. This is because of the water pressure, which is higher at the top of the pipe over there and decreases along the length of the pipe, and finally reaches on the syntax over here. We use what is known as the hydraulic grate line, which means that the hydraulic pressure decreases along the length of the pipe, and it will be something like this, the hydraulic grate line. So this is how we used to measure the hydraulic pressure along the pipe flow. There are some losses which you have to consider here, and some of the equations which we use is the Darcy-Weisbach equation, and if you are a student of fluid mechanics, then you may feel moody looking at Moody diagrams, so you may also consider using the Hazen-Williams equation. I'm not going to bore you with these equations, but very briefly, which I can tell you is, don't use the length of the pipe to be too long, use the shortest route possible. And as long as possible, don't use pipes which are too small. This factor is very important, as the diameter of the pipe really affects the head loss of the flow. Head loss, you may find it funny, which means you may think of it as like headhunters in the northeast, but it's something which the pressure loses along the flow of the pipe. So talking of pressure, as elections are coming on along now, both in Nagaland and in Meghalaya, the unit of pressure in the SI units, which you might have studied in school, is pascals, but as engineers we usually use the unit bar. So an easy way to remember is, if you have a lot of pressure, then you go to the bar, and if you're in Nagaland, then you know that dry state Huilivi mundu to ene pai kutu Huilivi, and if you're from Meghalaya, then Filatip he shop open kamut ayu. Anyway, with this slide on a lighter note, I'd like to end this video. Please keep watching my videos, and this concept of pipe flow will be used in my upcoming video, which will be on Pico Hydel project. Thank you.